What is the human response to climate change? We'll talk about two things. One is the science that verifies that there's climate change, and the Intergovernmental Panel on Climate Change that is expressing that science. And we'll talk about the policy, and that is, what are the countries agreeing or not agreeing to do about climate change and how to mitigate it. And we'll talk about the conference of the parties and the meeting of the parties that meet every year. And we want to think about what the role of the United States is in all this. So this shows the rise of greenhouse gases for the different countries. One important thing to keep in mind is we have the USA and China here. China emits slightly more than the US right now. However, they have 4 times the population, so their emissions per person are about 1/4 of ours. Furthermore, a good portion of this increase in carbon dioxide emissions comes from the export business of China to the United States. And I've heard the term that China is the exhaust pipe of the United States. In any case, the Kyoto Protocol was written in 1997, whereby we first said we're going to limit carbon dioxide emissions, and we enacted it in 2005. And here are our emissions right now. We can break down the emissions in categories where the black line is total emissions. Looks very much like this line right here. And we can see that solid emissions, mostly coal, were initially predominant, and then looks like they're going to be predominant again as coal resources are not running out, where liquid or petroleum peaked and is probably not going to continue to rise too much as we reach peak oil. Natural gas is in brown, and green is interesting that cement has its own category. And why is that? Well, when we make cement, calcium carbonate is heated to produce quicklime. This is the main ingredient of cement, and a CO2 molecule is released. Furthermore, in heating, we have to burn most likely coal in order to heat the calcium carbonate, which emits approximately 1 molecule of CO2 for every molecule of calcium oxide produced. And so 50% of cement emissions come from the released CO2, and the other 50% come from heating it. The last category, flaring, is when we burn natural gas or some emissions that come from the ground associated with drilling. Here we see the rise of the emissions of developed countries, and developing countries are growing faster. Keep in mind there are many more people in developing countries, and so on some level they could be thought of as just catching up. Most emissions come from CO2 with related to energy conversion. However, it's worth noting a large portion comes from what we call land use changes. And that is when we cut down forests and all of the embodied carbon in those forests is released into the air, and the forests no longer fix carbon dioxide through photosynthesis. We read this article, Industry Ignored Scientists and Climate Change. We learned about denial and the Competitive Enterprise Institute, and we saw the video. There's reports of record rise in temperature, and we can look at January 2011 and see that temperature is on a steady rise, certainly since the 1960s and 70s. Now it's worth noting there are a number of strong climate change deniers that say there has been no increase in the past 10 years, and you can see how we could look at these data and say it's been flat from about 1998 to present. But this is a result of a significant amount of error or variation due to weather. When we look over longer timescales, it's clear that there's a steady rise in temperature. Also, we're not heating uniformly in the Arctic regions, also in some desert regions. There's a lot more heating than in the equatorial regions. The Arctic regions are heating more largely because of the positive feedback mechanism of as the ice melts, it exposes dark areas to the sun rather than white areas. This is a positive feedback mechanism. The retreat of the Arctic ice cap, the yellow line indicates the median over this 20-year period. And we can see in 2007, we can see recently there's been a significant retreat of the Arctic ice cap. And there's a very real prediction of us having an ice-free Arctic in the near future. and we look at what is the international response, what kind of leadership do we get from our countries in response to this. And it's almost amusing that the response has been to bicker over the rights to gas and oil that are going to become accessible to us in this region when there's no ice. And in a particularly interesting example, the USSR planted its flag from a submarine under the North Pole, claiming this land for the USSR. This shows a steady decline of the Arctic ice cap from 8 million square kilometers down to about 5 right now. And this was the particularly low point in 2007. We should understand that no sea level rise comes from melting of floating ice. Because it's floating, it displaces the same amount of water when it's melted and when it's solid. However, we get sea level rise from 2 other areas. One is very simply that when water warms, it expands. And so the oceans are warming and they're expanding. Now, it's not a large amount of expansion. It's a tiny amount percentage-wise, but the oceans are very, very deep. And so that little bit of expansion is manifesting itself as a sea level rise. The other contribution comes from ice melting off of land. And in particular, Greenland is a concern, where we can see significant melting right now. It's recently been accelerated with a potential positive feedback mechanism. The increased water from the melt goes to the bottom and lubricates the surface between the glaciers and the rock and speeds the motion of the glaciers off into the ocean. So this could be a significant factor in the future, because once a glacier is in the ocean, it melts very quickly. All of this ice over Greenland represents 23 foot of sea rise. So what would that look like? It would look something like this. This graph shows with Greenland melted, and this one shows with Greenland and Antarctica also melted. Now, it's worth noting this is going to take a while to happen, like over the course of 100 years. But for Florida, I mean, this represents a significant amount of real estate. Where are these people going to go? Well, the United States is rather wealthy, and the people here will likely be able to move in with their children, or they'll find another place to live. But Bangladesh, it's very low-lying and impoverished. There are 150 million people, so 75 million people may live below the 20-foot line. Where are these people going to go? These people likely have nowhere else to go, and it represents a dire situation for them. We can see other instances of glacial retreat, it's called, and we can graph it here, where we look at above is the amount of glacier we lose every year in centimeters per year. And here is the cumulative loss since 1960. And we can see that on average, there's been 14 meters of glacial loss. So that's what, 42 feet, 43 feet thickness of glacier has been lost since 1955. There's also reports of increased hurricane intensity with the increase in temperature. Theoretically, this makes sense because hurricanes happen in the summer when there's higher ocean temperatures. So if global temperatures increase, hurricane frequency and intensity could also increase. We see an increase in the global mean temperature. We see an increase in sea level rise. And we see a decrease in northern hemisphere snow cover. And an increase in drought. We can summarize the signs of global warming. Besides the obvious of a steady increase in temperature over the last 40 years, we have a steady sea level rise, shrinking of glaciers, melting of permafrost. It's worth noting there's another positive feedback mechanism here. In the permafrost is locked a lot of methane. As the permafrost melts, more methane is released into the atmosphere, which exacerbates global warming. We have an increase in the growing season of 1 week in the northern hemisphere. Plant and animals are migrating north to cooler areas to maintain their same environment. Please read the rest. And lastly, what's not here and potentially very important, because this is what affects us the most, is that there are mass extinctions. And some scientists now refer to this as the Anthropocene era, where we've actually created a new geological niche because of the mass extinction that is happening right now or is projected to happen with increased global climate change. So we covered the physical and biological effects reported by the IPCC in global warming. And now we'll move on to policy.